Okay, so this video is about an equation that we have on chapter 6. So in chapter 6 we have two equations, but in this video I'll only cover the first equation, and in the next video I'll cover the second equation. So this is the equation that we have on chapter 6. This is the first equation that we have. This equation contains of three variables, n, c, and v. The n stands for index of refraction, and this n is a unitless quantity. It's a unitless physical quantity with no dimensions. It's dimensionless, or you can say unitless, and it's called index of refraction. Index of refraction, the definition for it is, index of refraction is the ratio between the speed of light in vacuum over the speed of light in a certain medium, in a given medium. So this will be the definition. And this n, this index of refraction, is a physical quantity that each medium has a different value for it. Like water has a different n, has a different value. The index of refraction for water is something, and for air it's something else. For vacuum it is something else, and for glass it is something else. We have a table in the book, actually, on page 144, in which all the index of refraction of various substances, of various mediums, have been found, and you can see all of them, all the values for n in that table. So basically each medium has a different n, has a different value for index of refraction. And what is important is that the bigger the index of refraction gets, the slower the speed of light becomes in that medium. And this is why v is inversely proportional with n, as you can see. The v is in the denominator, and if it's in the denominator, that means it's inversely proportional with this variable that we have, with this quantity that we have. So n and v are inversely proportional, which means the bigger the n is, the smaller the velocity in that medium will become. And of course this c here is a constant value. This is the speed of light in vacuum. So c is the speed of light in vacuum, which always equals to 3 times 10 to power which always equal to 3 times 10 to power 8, and the unit for speed is always meters per second. Okay, so this is this value here, c, and the speed of light in a medium is always smaller than 3 times 10 to power 8, because when light travels in a medium rather than in vacuum or in empty space, light will slow down. And the reason why it slows down is because of n. N slows it down. The index of refraction slows the speed of light down in that specific medium. So we denote the speed of light in vacuum as c, which equals to 3 times 10 to the power 8, and we denote the speed of light in a medium, in a certain medium like water or air or glass, as v, which is slower than the speed of light. Now, in equations, when we need to solve it, like, for example, if we need to solve a problem, usually the c is given, or the c is known. Like a teacher would not bring a question for you in which the question says, find the speed of light for me in vacuum, because you will know it without even calculating it. You will know it right away, without even using your calculator. You just know that the speed of light in vacuum is 3 times 10 to the power 8. So I will not make this the unknown. This will not be a good unknown, because every student knows the answer. What is good to be unknown is the index of refraction or the speed of light in a certain medium. So usually I'll either make this the unknown, the index of refraction, or the speed of light as the unknown. If the n is unknown, I have to give you the speed of light in a medium. I have to give you the v. And if the v is unknown, I'll have to give you the index of refraction of that certain medium. So one of those two will be given, the other one will not be given. You will have to find it. So let's solve a couple of problems so that you get used to that equation. It says the speed of light in a medium. So if it's a speed of light in a medium, not in vacuum, if it is in medium, we denote it as v, small v. This is the speed, which equals to 2.5 times 10 to the power 8 meters per second. As you notice, this speed is slower than the speed of light in vacuum, because the speed of light in vacuum is the fastest as you can get. So then it says find the index of refraction in that specific medium. So what will be the index of refraction? We need to find n. N equals to what? So we know the equation. Let me change the color. The equation is very easy, only contains of 3 variables. N equals to speed of light over velocity. the speed of light in a certain medium. So the speed of light c in the speed of light in vacuum equals to 3 times 10 to the power 8, and of course the unit is meters per second. And then we have the speed of light in a certain medium. It is given. I have given it here in this question. It says 2.5 times 10 to the power 8. Right? So let's divide that and put it in the calculator to see what we get. But you should know that the speed of light in a medium, the unit for it is again meters per second. So now you have meters per second in the numerator and meters per second in the denominator. So what will happen if you have 2 meters per second like this? Of course they would cancel each other. And this is why the index of refraction, n, is unitless. That's the reason, because both of the units will cancel. This will cancel this out, so you're unitless. No dimensions. Alright, so let's divide 3 times 10 to the power 8 with 2.5 times 10 to the power 8, and we will get 1.2. Yeah. So the index of refraction of this medium is 1.2, and I really don't need any units. No units here, only a mathematical value, and that's it, only a number, because this n is unitless. So this is how you find n. This is how you find index of refraction. I'll give you the speed, you'll find the n with this equation. Very simple. And then, what about if the index of refraction is given? This time the n is given. Let's say that the n is for water is 1.33. And I ask you to find the speed of light in water. So here you have to find the speed of light in a certain medium, which means you need to find v. What is v in this case? Alright, so again, we have the equation. The equation says n equals to speed of light over velocity in that certain medium. So what we do in order to find v, in this case the n is given and also the c is given. I mean, of course the c is not given, but you know it. It's 3 times 10 to the power 8. So the n is given, the c is known. You just switch places. Switch places and isolate speed of light in a certain medium, which means v. So this way, this is how the equation will turn out. Let me change the color. So the equation will be v equals to speed of light over index of refraction. We know the speed of light, it equals to 3 times 10 to the power 8, and the unit for speed of light is meters per second. How many meters light covers in a second? It covers 3 times 10 to the power 8 meters in a second. And then the index of refraction for water is 1.33. 1.33. No units. And then we divide that. Let's see how much we get. I think we get 2.25 or something. But let me make sure of that. Yeah, we get 2.25 times 10 to the power 8. And what will be the unit? Meters per second divided by no unit, you get meters per second again, because the denominator doesn't play a role, only the numerator plays a role, and the numerator is meters per second. So meters per second divided by nothing, you still get meters per second. And that makes sense, because this value that we have here, this quantity, is speed, and speed is always meters per second. I mean, this is speed, this is still the speed of light. So this is how you solve this equation in chapter 6. And this is the only 2 possible cases. If you have v, you find n. If you have n, you find v. And that's it. Very simple.